Now we're going to talk about the stage 3 of the Atom Project. Our goal for the stage 3 clip is that after you watch this, you can be experts in physical and chemical properties. First, we're going to talk about how we made distinguished substances.
Kevin, are you ready for your experiment today?
I'm totally ready today.
Let's start.
Wait, Ashley. We don't know which one's baking soda and which one's salt.
Kevin, I told you to label it.
Well, because their physical properties are so similar between baking soda and salt, what should we do now?
Oh, we have chemical properties. Since vinegar reacts with baking soda and vinegar does not react with salt, we can put a drop of vinegar in each substances and we'll know what is what.
Actually, that's a brilliant idea. Wait, can't we just taste it? Which one's which?
Why can't we taste it? Oh, hi, Mr. Tay.
Hello.
Can we just taste the substances?
Please.
No, these are very dangerous.
It's much faster.
One of these may be toxic to you.
Oh.
Please, Mr. Tay.
Let's
Just
do
put
the
vinegar.
experiment.
Okay, let's try
Okay,
putting a drop of
let's-
vinegar.
Okay. Oh, this one is reacting.
Wow.
And
It's forming bubbles. Let's try this
this one's not reacting. So it means that this one is baking soda and this one is salt.
And we were able to find this out because baking soda reacts with vinegar while salt doesn't.
So we use both properties to figure out what is what.
Actually, remember that we always have to label which one's which in our next experiment.
Yeah. Okay, now we can start.
Now we're going to talk about the most essential physical properties.
So today, because we learned about the states of matter in our stage 2, let's start talking about the physical and the chemical properties.
We're gonna first learn about physical property, and the first property we're gonna learn about is solubility.
As we know, solubility is about salt actually dissolving into water. So we have salt here and water here.
It doesn't have to be salt. It can be any material substance dissolving into another substance.
So first, for this experiment, we're going to talk about salt.
Yeah.
Because it's the most thing most people know about. So we're going to put salt
In
inside
clear water.
beaker.
As you can see, there's salt in it,
A
and
little bit more. More in.
yeah, and you can see the salt clearly. And now we're gonna dissolve it by
We're going to mix it with water. It may take some time. But at last, we guarantee that the salt will actually dissolve into this beaker of water.
salt has a physical property of solubility that is able to dissolve in a lot of liquid, like this.
And this is one of the unique properties of salt, which
Yep.
is a physical property.
Yep.
As shown now, as we can see, the color of the water is sort of blurry, and this is because the salt actually dissolved into the water and became part of the water.
Yep.
And this is one unique characteristic of salt.
Yep. And this is solubility.
So this was our first step in our physical properties. Thank you.
Thank you.
So our second stage to our physical properties unit is about malleability. So Professor, what exactly is malleability?
Malleability is the ability of a substance to be folded and pounded.
So it's that simple.
Yeah, look. This aluminum foil can be folded like this,
How about pounded?
and it can be pounded. Wait. See? So this has malleability.
Wait, if science was that simple, that means that all matter can actually have malleability. Can you try it with this little doll?
This doll doesn't have malleability because first of all, it can't get folded. See, it just pops back up, and it can't get pounded. So there's no reaction to the pounding.
Maybe it's just because it's a doll. Try it using this. Maybe this may work.
This definitely does not get folded. You can't do it, and that it doesn't get pounded, and the shape doesn't change. So this doesn't have malleability either.
So are you saying that malleability is also unique physical properties of only certain matter?
Yep, like aluminum foil or paper or these.
And like always, our unit was a success today of the stage 2 of our physical property.
Yay!
Thank you. Hello, Miss Professor.
Hi.
So now we are on our third unit about physical property, which is about ductility. So first, let me ask you, what is ductility?
Ductility is an ability of a substance to be pulled into a wire.
So, is that for a lot of substances?
Not necessarily. Take a look at this aluminum foil.
Wait, this was the example we used in our second stage, which was about malleability.
Oh, this is a very good example because it has a lot of properties.
So, an object can have 2 or more physical properties?
Of course!
Oh, so can you explain to us how this has ductility?
This aluminum foil is ductile because if you bend it or if you twist it, it stays that way. Like elastic band, if you stretch it or if you twist it, it doesn't stay that way. So this substance is not ductile. Well, this is because it stays that way.
So is it essential for a substance to have ductility if it could stay in that position?
Yeah.
Oh, okay. Thank you. And this was our third stage of our physical properties, which was about ductility. Hello, Miss Professor. Today, it's our fourth unit about physical property, which is about magnetivity. So first, let me ask you, what do you think magnetivity is?
I'm not sure today. What do you think, Kevin?
Well, magnetivity is the attraction between two certain materials where the attraction is not visible because you can't see the visible attraction between these two, but there is certain attraction between these two substances.
Oh, so are you saying that this has magnetivity because it's 6 magnets?
Yes.
Like this?
So you could basically test something out if it has magnetivity or not by just sticking it to a magnet.
So you're saying that this doesn't have magnetivity because it doesn't stick?
Yeah,
right?
as we can see with our eyes, it doesn't stick. And another example is this crayon. So this doesn't stick. But now let's give an example where there is magnetivity. Let's try this pin. As you can see, it directly sticks to this magnet, which means that this pin has magnetivity. It's really simple stuff, right?
Oh, okay, I get it.
So that's our fourth unit about physical property, which was known as magnetivity.
Okay.
As you can see, this is aluminum foil once again. As you can see on the right side, it is really burnt. However, as we touch the left side, it is also very warm. This means that this aluminum foil has great thermal conductivity. In other words, heats really well. And as we wipe off the burnt side on the right side, it gets wiped off really easily. This means that the burnt place is not actually part of the alumina, but just a product of the wood oxidizing. Now, the last physical property is electrical conductivity. Similar to thermal conductivity, electrical conductivity tests if a substance can actually get the electricity very well and very fluently. As you can see, as these two cords meet together, the light bulb seems to flash out, which means that it has great electrical conductivity. Now, let's talk about chemical properties.
First one is about flammability. So first we're going to test this out of what flammability is. So flammability is the ability of a substance to actually burn. So there's this piece of paper, and with this lighter, we're going to actually try. So it's burning right now, as you can see, which means that paper actually has good flammability. It's burning in very fast speed, which shows that it has very good flammability.
Hi, Kevin.
Hey Ashley.
What are you eating?
Well, it's a tangerine right here. So I like eating tangerine, but the purpose of me eating it right now is because we want to talk about the second unit about chemical properties, which is
Digestion.
So I know this may be an awkward topic. First, I'll try eating this tangerine. I'm ripping the cover off because of course we don't want the cover inside our belly.
So what happens during digestion?
The digestion is when you eat a certain food, and after it comes out, it comes into different form, which shows that the substance actually changed, which is why it's chemical property, not physical property.
Oh, but it does physically change too, right?
Yes, of course, because the shape of it actually changed, but more importantly, it's a chemical property because the form of it has changed. So I'm eating a piece of tangerine right now. And of course, we can't show the aftermath, the product, the byproduct of this. But as we eat this, and as this tangerine goes into my belly, it gets mixed with other chemicals in our body
So it's just acid.
and comes out our body in a different form.
Yeah.
So this was all about digestion. And remember that although tangerine looks so cute in this format right now, after you eat it, it's gonna come out as a wasted form. So this was our second unit about chemical properties.
Lunch is over. Let's get back to class.
Now, it's our third unit of chemical properties.
Oh,
A lot of
look.
rusting here.
This is rusting. Hey, by the way, Kevin, what is rusting?
Well, rusting is when a substance meets with oxygen and actually oxidates, which is why oxygen is such an important during the process of rusting.
Oh, so the substance changes when it's rusting, right?
Yeah, as you can see, it feels as if only the color has changed, but it's not true because it's a chemical property where actually most of the atoms have and the molecules actually reformatted themselves.
Oh,
So
new metal like this doesn't rust, right?
yeah, and this may be because also of the color, but it's mainly because this is metal, and maybe because this is not.
Now we're going to talk about the fourth chemical property, which is reactivity. As the name suggests itself, reactivity when a substance reacts or combines with a different substance to make a new substance. In this case, it's aluminum foil. Yes, aluminum foil has a lot of chemical and a lot of physical properties. And this is when aluminum foil actually reacts or combines with hydrochloric acid. As you can see, bubbles are forming. And bubbles are a sign of chemical properties because it's making a new substance. As the hydrochloric acid mixes with aluminum foil, lots of bubbles are coming out and making this different shape of color. Although shape and although color are physical properties, the atoms actually rearrange themselves in this case, which is known as reactivity. Now we're going to talk about the last chemical property.
Another type of chemical property is oxidation. Specifically, we will be looking at the lipid oxidation. A lipid oxidation is the reaction between the oxygen and the unsaturated fatty acids, which might result in discoloring of the fruits. The apple on the left is the apple before the oxidation occurred, but the apple on the right is the piece of the apple after the oxidation occurred. After a few hours, the apple will turn brownish yellow due to the oxidation, where the unsaturated fatty acids of the apple reacts with the oxygen, and its flavor will change too. Therefore, we can observe a chemical property of the apple, which is oxidation, and that after this process, there will be a lot of loss in the nutrition.
Now we're going to talk about the appropriate usage of materials based on a substance's physical and chemical properties.
Hi, today we will discuss which substance is the best for removing a stain. The two choices are water and detergent. First, the physical properties of water are that it is clear, transparent, is a liquid, has surface tension, and can absorb heat. Also, the chemical properties of water are that the pure state of water has a neutral pH and it is a universal solvent, so it is able to dissolve many variety of chemical compounds. Second, the physical properties of detergents are that they are in a liquid form, are white, and smells refreshing. In addition, the chemical properties of detergents are that they contain both polar and non-polar components, and the non-polar portion of the detergents are commonly used for cleaning purposes, like grease. Also, detergents contain enzymes, which is used to remove stains that are made up of proteins, fats, or carbohydrates. Looking at these properties of the two substances, we can clearly understand that choosing the detergent to remove a stain would be a lot more efficient than using water.
As you can see from this video, we can say that physical and chemical properties are essential to our lives. This is because we can decide and act upon what we have to do based on these properties. Thank